morning! Today we are going to talk again about bots and whisker plots, but interpreting data. So today what we're going to see is still chapter 10, lesson 2b, but we're going to see part 2b, which means just a little, some more examples of how to work with box and whisker plot. The objective is more interpreting data in a box and whisker plot. So let's see what the examples that we have here. But before that, let's do a quick recap. Okay, let me move over here. All right, so to build a box and whisker plot, we need the following information. We need the median, which is the middle number of the entire data set. We need the upper quartile, which is the median of the upper half of the data. We need the lower quartile, which is the median of the lower half of the data set. And we need the greatest and lowest values, which are the biggest and smallest numbers in the entire data set. And then we need the range. Range and outliers is something that we might need, so we just need to be watching for them. The range is the greatest number in our set, take away the lowest number in the set. And then we need to see if there are or not any outliers. And what are outliers again? They are the numbers that are either much greater or much smaller than the median. So let's see our first example here. Our first example shows that the data below shows the number of laps a student can run around Boca Christian non-stop. So if that's one of you, here's the information that we got. So here is our data set. We have people that can only run one entire lap, and we have people that can do 12 with non-stop. So first we're going to find the necessary information to make our box and whisker plot right here. So first of all, let's find the median. How do we find the median? The median is the number that is right in the middle of our data set. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 12 numbers. So we have to divide this in half. 1, 2, 3, 4, 5, 6. 6 on one side, 6 on the other side. But what is the number right here in the middle? So the median is calculated with the two numbers in the middle, since I don't have just one number there. So this is 4 plus 5 divided by 2. 4 plus 5 is 9 divided by 2, 4.5. Then I have to find what? The upper quartile and lower quartile. Upper quartile is going to be the median that is, upper. Upper is this side, the higher numbers. So it's the number that is going to be the median in this data set right here, half of what I have. So 1, 2, 3, 4, 5, 6. I get the two numbers right in the middle. So I have what? 7 plus 8 divided by 2. 7 plus 8 divided by 2, 7.5. Then I have the lower quartile, which now it is this side over here. So the smallest numbers or the lower numbers on my data set. So I have 1, 2, 3, 4, 5, 6. So these two numbers here are right in the middle. So I get those. I should do 2 plus 2, 4 divided by 2 is 2. But since they are the same number, then that's what I get over here. Now I need what? Greatest and lowest values. Those are the easiest ones to find. Greatest here, lowest here. So the greatest is 12, the lowest is 1. Range. Range is what? The difference between the greatest number and the lowest number. So this is 12 minus 1. The range is 11. And then outliers. For me to find if there are any outliers in my data, what do I need to do? Let me put this on the side. I have to use my interquartile information. So how do I find what is the interquartile range? The interquartile range is the difference between the upper quartile and the lower quartile. So this is 7.5, take away 2. 7.5, take away 2, this is 5.5. For me to see if I have any outliers, what I have to do, and I'm going to do it on this side over here. What I have to do is to do what? I get my interquartile number here, which is 5.5, and I'm going to multiply that number by 1.5. So if I get 5.5 times 1.5, I am going to get 8.25. This number here is the magical number that I am going to use to check if I have or I don't have outliers. How do I do that? I get my upper quartile and I am going to add this number here, 8.25. And then I am going to get my lower quartile and I am going to take away 8.25. I am using all the space here, then I'll have to erase something in order to graph, but that's okay. The upper quartile is what? 7.5. So I have what? 7.5 plus 8.25. When I add 7.5 with 8.25, I have 17.75. 15. Sorry. This is 15.75. And then I have what? What is my lower quartile? It is 2 take away 8.25. So when I do 2 minus 8.25, I get a negative number. Negative 6.75. Okay? 6.75. So what do I do here? When I am working with these numbers, I have to see what? I have to see if the numbers that I have on my set are either greater or smaller than this. So if they are greater than 15.75, they go here. If they're smaller than this, and see, we got a negative number here. So if we get a negative number, we don't have any negative numbers here. So there are no outliers. Just so we can be, just that we are able to do this, I am going to erase this information here, keep the numbers that we need. So we see, so we are able to graph over here. The interquartile range is 5.5. So let me take this from here so I have room to graph. And this is 11. So now I have room to graph. So what do I need here? I need the median, 4.5. So I come here, mark my first point. So this point is going to be right in the middle, 4.5. And then I need my greatest value and lowest value. Lowest value 1, greatest value 12. And then I have upper quartile 7.5 right here in the middle, and lower quartile 2 right here on number 2. So I get the points that are right here. They go from the lower quartile to the upper quartile. I divide with the median and I do here my whiskers. Okay, no outliers for this example. Now we're going to see example number 2. So I am going to erase all this so we can go and proceed to the next example. All right, so this is the second example. A website published some statistics about how long babies spend watching TV each day. This box and whisker plot shows the results. So look at this. We have babies watching TV 30 minutes and babies watching TV for 60 minutes. This is the interval or the range in my information. So here the question is, what percent of babies watch TV for 40 minutes or more? So what do? I go to my 40 minute, which is right here, and I see that I have, remember, each one of these marks here is 25% of my information. So 25 there, 25 here, 25 right here, and 25 more over here. So each one of these represents 25% of my data. So if I want to know what percent of babies are watching TV for 40 minutes or more, I'm right here. So I have what? 75% are watching TV for 40 minutes or more. What is the minimum amount of time the babies spend watching TV at a given day? That's easy. We just have to find our lowest number. So that is 30 minutes. And then what is the interquartile range of the data? The interquartile range is exactly the number from here to here, the difference between these two information. So here, there's no number, but this is 55. 30, 35, 40, 45, 50, 55, 60. So the interquartile range is going to be what? 55 minus 40, which is 15. And then the last question, are there any outliers? So just looking at the information, we see that there are no outliers. First, because they are not marked, because outliers are marked in our graph. So here, I have no outliers marked. But how can I be sure? So let's go once again and find the outliers here. Or if there are none, then we'll find that we don't have any outliers. So the first thing I have to do is what? I have to get my interquartile range, which is 15, and I multiply it by 1.5. When I get 15 and I multiply it by 1.5, I get 22.5. All right, 22.5 is the magical number that I am going to add to the upper quartile, and I'm going to subtract from the lower quartile. So my lower quartile is this one here. So 40 minus 22.5. And the other one that I have to do is my upper quartile, 55 plus 22.5. So when I solve that, I have that 40 minus 22.5 is 17.5. And then 55 plus 22.5 is 77.5. Look at this. I have no numbers greater than 77.5. And I have no numbers that are smaller than 17.5, because my smallest number here is 30. So are there any outliers in the data? No, there are no outliers. All right, so we are ready for our last example. Let me change the slide. All right. Here is our last example. Our last example shows a box and whisker plot here, and it says, what is the range in the test score? Well, this is the test score for, let's say, a math test. So the range in the test score is what? The highest score that was received by a student, taking away the lowest score that was received by the student. So this is 100 minus 70. So the range in the test scores is 100 minus 70, which is 30. Which quartile shows the greatest spread of data? So where do I find the greatest amount of information? Which quartile shows the greatest spread? Here I have my lower quartile and my upper quartile. So look at this. This one here, the difference from 85 to, this is what, 77, is smaller than the difference between 97 to 85. So if we just look at the graph, we see that the majority is concentrated in this area here. This is the greatest area. So the upper quartile is the one that has the greatest spread of data. And then what percent of students receive more than 85% on their test? So if these here are the grades, what happens here? 85 is right here. Look, it's right in the middle. That is the median. That is the middle of my data, which means that what percent of students received more than 85? 25% here, 25% there. The students that received more than 85% on the test, half of the students did wonderful, got 85 and more on their test. This is it for today. So now I'm just going to assign some homework and I'll see you tomorrow. Here it is, page 602. You just have to do two problems, 10 and 18. And they are due on Tuesday, March 31st. No, they're not due by 7:59 a.m. They're due by midnight. So you have until tomorrow, Tuesday, to do this, and you have to turn it in by midnight. See you tomorrow.